Hi everyone, I really hope guys the videos we keep sharing for both maths and science are helping you out preparing towards your final exam. Please guys, don't forget to subscribe if you are new to the channel and tell your fellow peers to come and join us master these topics. The aim is to chow course bantwana bam. Okay, the video will be just about question 5 from the 2022 Eastern Cape final examination. It's a grade 11 question paper, by the way. We are still under the topic of quantitative aspects rather of chemical change. So we'll just do question 5. Okay, we are told that in an organic compound rather has the following compositions. Carbon has 54.55%, hydrogen is only 9.09%, and then oxygen is 36.36. Okay, and then we are told that the molar mass of the compound is twice the empirical molar mass. Okay, we will need this statement whenever we find the molar mass of the compound. Okay, now let's go. We are told to define the empirical formula. Okay, the empirical formula, guys, is just the smallest whole number ratio of elements that makes up a substance. Okay, please write it down. A smallest whole number ratio of elements that makes up a substance. Then secondly, we are being asked to determine by calculations the molecular formula of the compound. If you are given a situation like this, guys, you must obviously find the empirical formula first. If you are given the content of elements as percentages, we must always change it to the mass of each element. Are you together? Which simply means that for carbon I have 55.55 grams. I'm going to write here on my table like this. For carbon I have 54.55 grams, right? And then for hydrogen I was given 9.09 grams. Oxygen is 36.36 grams. Are you together? All in all, they make up 100 grams. Okay, and then I must write down their relative atomic mass number for me to find the number of moles which are contributed by carbon and hydrogen and oxygen for us to have a complete organic compound. Okay, the relative atomic mass number for carbon is 12. Please guys, if you're not sure, just go down there on your periodic table, right? On your periodic table we are looking at carbon. Here is carbon then, eh? This number here is the relative atomic mass number, 12. Are you together? Hydrogen is here. This is the number. And then for oxygen we have 16 there. Are you together? And we are going to take the molar masses and find the number of moles. We're going to use this equation. The equations, guys, are always at the back of your question paper. The equations are always at the back of question paper, right? So molar mass for carbon is 12 grams per mole, and then for hydrogen is 1 gram per mole, and then oxygen is 16 grams per mole, right? So for me to find the number of moles for each, I'll simply use this equation. Number of moles is mass all over the relative atomic mass number. Are you together? So this thing simply means that for carbon I'll simply say 54.55 divided by 12 What do I get? Let me just round it off to 2 decimal. It's 4,55 moles. Okay, and then for hydrogen, I'll simply take 9.09 divided by 1, still 9.09, right? 9.09 moles. And then for oxygen, it's 36.36 divided by 16. I'll simply get 2.27 moles altogether. So for me to find the ratio, guys, I must simply take the one with the smaller number of moles and then divide each and every number of moles by the smallest one. Are we together? I'll take the number of moles of carbon, divide by 2.27. Why? Because 2.27 is the smallest number of moles, right? That's how I find my ratio. So I'll simply say 4.55 divide by 2.27. I'll get 2.004, which is approximately 2. Are you together? Remember that, guys, empirical formula is the smallest whole number value. That means whenever we find our ratios, we must always round them off into whole numbers. Are you together? Same thing applies with the hydrogen. Divide that by 2.27. I'll get 4.004, which is approximately 4. And then 2.27 divided by 2.27, I'll get a 1. So this thing simply means that, guys, for my empirical formula is like this. I have 2 carbons, 4 hydrogens, and 1 oxygen. Are you together? This is my empirical formula. And the molar mass for my empirical formula, I have 2 carbons plus 1 hydrogen and 1 oxygen. What do I get? 12 times 2 plus 1 times 4 plus 16. Excuse me. I have 44 grams per mole, right? Remember that, guys, I was told that there by the statement, I was told that the molar mass of the compound is 2 times that of the empirical molar mass. This was the empirical molar mass, right? That means this thing simply means that the compound's molar mass is going to be 2 times 44. Then it gets 88 grams per mole. So to answer this question, I have 88 grams per mole. It's 88 grams per mole. Okay, and then we are told that a teacher demonstrates to a group of learners the impact of limiting reagent. A teacher demonstrates to a group of learners the impact that the limiting reagent have on the amount of product formed during a chemical reaction. The teacher uses the following chemical equation. We have zinc, which is being reacted with hydrochloric acid to form zinc chloride and hydrogen gas. Okay, the teacher uses the following setup for the investigation. Okay, in experiment 1, the teacher placed 7 grams of zinc inside the acid, which had 1 mole. Are you together? And then for the second experiment, the mass decreased to 3.27 with the same amount of acid. Okay, the first question says, define the limiting reagent. The limiting reagent, guys, is the substance that will be completely used up in a chemical reaction. All together. Since it will be completely used up in a chemical reaction, just know that it is the one that determines the progress of the reaction. All together. Once one substance is completely used up, the reaction will reach completion. Right, together. So the definition simply says is a substance that is completely used up in a chemical reaction. Right, together. And then question 5.2.2, we are asked to determine by calculation the limiting reagent in excuse me, in the first reaction. The first thing I need to do is to calculate the number of moles for zinc, because I do have the number of moles for the acid, right? The number of moles for zinc, I know that number of moles is always mass over the molar mass, right? I'll go down to my periodic table and check the relative atomic mass number for zinc. Zinc, this is zinc, right? My molar mass is 65. So the number of moles for the zinc solid, excuse me, it's going to be a mass over the molar mass, right? So I'll simply get 7 over 64. Is it 64 or 54? Let me go check. I'm concentrating. It's 65 actually. Okay, it's 65. So I'll simply say 6 divide, no. It's 6 divided by 65. I'll simply get 0.092 moles. These are the number of moles for zinc, right? The number of moles is just 0.092 moles. And then for me to find the limiting reagent, I just need to check which one between the two will give me the limited amount of products, the smallest amount of products, right? I know that zinc will always give me 1 zinc chloride. So if I have 0.092 of zinc, I want to know how much of zinc chloride will I form. Are you together? What I need to do is to just cross multiply. Whenever I cross multiply, I just focus on the coefficients, right? So in this case, 1 times 0.092, I'll get 0.092 is equal to x. So the number of zinc chloride which will be produced is 0.092 moles. Okay, and then let me check if I'm using the hydrochloric acid. I know that 1 HCl will always give me not one, rather, according to the reaction is 2 of them, ne? It's 2 HCl will always give me 2 zinc chlorides, but now I have 1 of them. Are you together? I want to know how much zinc chloride will I make. I'll put x there. Then when I just cross multiply, I'll simply have 1 multiplied by 1 is equal to 2x, right? Then x, which is the number of moles of zinc chloride, will be 1 divided by 2, which is 0.5. So we can see that zinc can only give me the products, the zinc chloride products as 0.092. However, hydrochloric acid can give me 0.5 of zinc chloride. So this thing simply means that zinc is my limiting reagent. Why? Because zinc will give me the less amount of products. Are you together? So in this case, zinc is my limiting reagent. Are you together? Okay. How will the amount of zinc chloride produced in experiment 2 compare to that of experiment 1? Write down higher than, lower than, or equal to explain your answer. Okay. The answer is lower than, guys. Yeah? Why? Because they've decreased the mass. Are you together? According to this equation, let me erase here for me to have space to write. There's an equation that says number of moles is equal to mass over the relative atomic mass number. Okay, the mass number for zinc just remains constant. It doesn't change. It's a constant term. But please note, guys, that if I decrease on my mass, I'll also decrease the number of moles. Are you together? So remember that initially I had 0.092 moles and of zinc, and it gave me 0.092 moles of zinc chloride. This time around, the number of moles will be lesser, guys. Are you together? The number of moles will be 3.27 divided by 65. The number of moles will be 0.05. This thing simply means I'll get 0.05 moles of zinc chloride. Remember that in this case, guys, zinc is our limiting reagent. Zinc is the one that determines the maximum amount of zinc chloride which will be formed. Are you together? So if we decrease the number of moles of zinc, we will be decreasing the number of moles of the zinc chloride which will be formed. That's the reason. Okay. And then we are told that in experiment 2, we are told that experiment 2 was carried at 40 degrees Celsius. The molar volume for hydrogen gas at this temperature is 25.7 decimeter cubed per mole. Calculate the volume of hydrogen produced once the reaction has reached completion in experiment 2. Okay, for experiment 2, guys, now please note that zinc is still our limiting reagent. Are you together? So if I can find the number of moles for zinc, I can simply find the number of moles for hydrogen. The number of moles for zinc, it's simply mass all over the relative atomic mass number. It's 3.27 divided by 65. All I'll get is 0.05 moles. This is zinc, right? But please note that one zinc will always give me one hydrogen. If I have 0.05 amount of zinc, I want to know how much hydrogen will I form. Just cross multiply. Then X is 0.05 moles. But what does X represent? It represents the number of moles of hydrogen which will be formed. 0.05 moles. Are you together? Since I'm given a molar volume, I must use this equation here because hydrogen is a gas as well. I must come to this equation. I have the number of moles. I'm given the molar volume. The molar volume is not the one is not this one. Why? Because this one is being held at standard temperature and pressure. 40 degrees Celsius is not standard temperature. Are you together? So that's why they've given me the molar volume at 40 degrees. So after this, I'll simply say N is volume of the gas divided by the molar volume. I know that this is 0.05. I want to know how much volume of the gas will I get. This is 25.7 decimeter cubed per mole. So for me to find the volume, I'll simply take 0.05 multiplied by 25.7. 0.05 multiplied by 25.7. So this is just 1.2, let's say 9 decimeter cubed. That's the amount of volume which was collected from the reaction of zinc and hydrochloric acid. I really hope, guys, the video was helpful. If you have questions, want clarity, please, guys, write there on the comment section, and don't forget, guys, to click the like button if you like the video, and share the video, guys. Help us grow the channel. Thank you very much.